So the last one is acceleration. So in velocity and speed, we had speed and we had velocity. There was one thing I forgot to mention. Direction. Because velocity has a direction, we consider that to be a vector, and speed a scalar. Okay? So when we get to acceleration, acceleration turns out to be a vector. So what we need is we need the scalar equivalence to acceleration. Well, we've got a problem here. Our vocabulary describes acceleration as both a vector and a scalar. And we also use other words to describe an object that accelerates. Braking. Deceleration. All these are referring to scalars and not vectors. So what does that mean? Well, when I use the word acceleration, what do you guys think? To speed up, to go faster, right? If I use the word braking, what do I mean? Slow down. If I use the word decelerate, what do I mean? Slowing down again. It turns out that all of these are referring to an acceleration. So when we talk about the acceleration of an object, we're talking about slowing down or speeding up an object. Okay? In either case, the object is accelerating. That's what acceleration means. Now, the equation for acceleration is, well, we had speed as a distance over time. We had velocity, which was displacement over time. Acceleration is the change in velocity over time, or the rate in which an object is either speeding up or slowing down. Cool? An example, car going 20 meters per second goes up to 50 meters per second and does that in 2 seconds. Its acceleration is going to be the change, which is 30 meters per second, and it's going to do that in 2 seconds, which means that its acceleration is 15 meters per second per second. Cool? Yes? Pretty straightforward? I can go the other way. So now it's 50 meters to 20 meters. The change is negative 30, and its acceleration is negative 15. Cool? Acceleration, being the change in velocity, has 3 ways in which driving a car you can affect the acceleration of a car. You can speed it up by slamming on the gas pedal, right? That makes the car go faster unless it's a piece of junk. Obviously, stepping on the accelerator of a Yugo doesn't necessarily make it go faster. Stepping on the brakes slows it down, so it's causing it to accelerate. And the last way in which a car can accelerate is by turning the steering wheel. You're accelerating because velocity is not only how fast it's moving, but how fast it's moving in a given direction. So if that direction changes, wait for my camera to settle down. If my velocity changes its direction, it's experiencing an acceleration. What's really cool about acceleration? It's sensory. You can feel accelerations. If I slam on the brake, you feel yourself falling forward. Slam on the accelerator, I'm falling backwards. Turning, I feel myself getting slammed into the wall. All of those feelings means that you're accelerating. So anytime you feel that, means that you're accelerating at that moment. Any questions about those concepts? Those are the basics of linear motion. From there, we're going to move on and we're going to apply some equations. But those are the key concepts. Cool?